Hey y'all! In this video, I'm going to answer 2 more of your Vectric questions. Even though I'm demonstrating this in Aspire version 10.507, everything I'm going to show you applies equally in vCarve Desktop, vCarve Pro, and Aspire. Now the first question I received via email at my website, marklindsaycnc.com, through the Contact Us page, asked about the zero plane and the modeling plane. The viewer said he was still a little bit confused as to what they were, what they did, and what the difference was. So let's go ahead and take a look at our 3D view. Right off the bat, I'll say that in Job Setup, I set this up. The material is 3/4 of an inch thick. What we have here in the 3D view with no models in this file at all is a blank canvas. This is the modeling plane. It looks like a grayed out or ghosted version of a piece of material, and that's exactly what it is. Basically, this is just a visual representation of the surface that our 3D model is going to be assembled on. Imagine it as the tabletop, and each of our 3D models is a separate component that we're going to put on the table in specific areas to build up that final composite 3D model. Your composite 3D model might have one component, it might have 20 or 30. It doesn't matter. This is just a visual representation of the surface that you are building that model up on. It has no height. So to demonstrate this, we can go over to our Clip Art tab, and I've gone into my Clip Art folder and into Domes and Dishes, and I'm going to go ahead and use a standard 30-degree dome dish, and I'll double click it to put one in the center of my material. And here we have that dome. Now, as you can see, the base of this dome is sitting on this modeling plane. That's all this modeling plane is. That's all it does. It is sized based upon what you entered for your material width and height in your job setup. There is no thickness. It's simply a visual representation of the plane that the model is going to be built up from. Now let's go over to the Modeling tab for a second. Something to remember in working with 3D models in vCarve and Aspire is that the software models from the bottom up. So the bottom of the model is this visual representation of the surface, the modeling plane, and everything we add sits on top of that. So we could come back over to the clip art and add more models either out here on top of the modeling plane or merge them into or add them on top of our dome here. So that is the modeling plane. Keep in mind that vCarve and Aspire both model from the bottom up. The zero plane is completely different. The zero plane is used for models and components that have a concave shape, that are not being added on top of the modeling plane, but rather are being modeled down from the surface of the material. So we need a way to visually represent that. Now let me go over here into my combine mode for this dish, and I'm going to change the combine mode to subtract. Suddenly it's a little bit different. Well, now instead of having that dome shape, we have a dish shape. We have a concave surface. If I go into the properties, I can see that the shape height is 0.3683, so not quite 3/8 of an inch deep. There's no base height, there's nothing else added to this model. But if we zoom in here real close, we can see we have some pretty jagged edges up here. That's because of the way Aspire create models. It's the way they're created. If we come back over here to our 2D view, we can see a grayscale image. This is how it's modeled. This grayscale image, the darker colors are the deeper cuts and the lighter colors are the shallower cuts. Now if we zoom in here real close to the edge, we can see that this fades from dark to light at a fairly regular rate. But out here it's kind of fuzzy, it's kind of blurry. And the difference between white and gray gets more subtle down in here. So when we come over to the 3D view and we zoom in close, we can see that that's what this edge is. Let me bring this up some here. We can see that that's what this edge is. This is where that gray fades into white and it's fuzzy and blurry. So we get a jagged edge on this. Zero plane is a visual representation of the surface of the material that this model is being carved into. So, again, remembering that Aspire and VCarve both model from the bottom up, we would place a zero plane above this model. Now we can put it on this level or we can put it on another level. It doesn't really matter which. When we come up here to add a plane component with zero height covering the model, we click that, and when it updates, we now see a visual representation of the surface of our material. We also see the thickness. We see a line here representing where our modeling plane is within that material. And we see the concave that dish is carving into the material. One of the side effects of this is that if we zoom in real close, we can see along the edge that zero plane has filled in those ragged edges. So a zero plane is used, generally speaking, for models that have a concave shape to them that is being carved into the surface of the material. The zero plane gives you that representation to show you how that is going to look once carved, rather than just a solid disc sitting on top of the modeling plane with jagged edges still all the way around the model. That's a very basic, very simplified overview of the difference between the zero plane and the modeling plane. Again, the modeling plane, think of it as a representation of a tabletop that all of your models are going to be built up from. And the zero plane, a representation of the surface of the material that your model is going to be carved into. The next topic we're going to discuss is the bit or end mill stepover. This is going to be specific to 3D carving. And I need to give you a warning, I am not suggesting or recommending any of the speeds or feeds or plunge rates that I'm going to show you here. These numbers are just for demonstration purposes. I had 2 emails and was tagged in a Facebook post on the same day asking me about stepover for a tapered ball nose. Now, this is a photo of a 1/16 of an inch tip diameter tapered ball nose bit. Not to be confused with a standard ball nose bit. You'll notice this is basically a straight shank with the cutting flutes and a ball nose. The tapered ball nose has this angle that helps to machine away material, the edges of the material, before the tip of the ball nose gets to it. The first email I got was asking me about what do I do when I have a 3D model that has a long cut time. And as we discussed it, he basically told me that he had a model that was going to take 30 hours to carve. So after further discussion, what we got into was he sent me a picture of his settings, and here was his problem. He had his Stepover set to 2.5% of the bit's cutting diameter, which is down here. In this case, this is a 1/16 of an inch ball nose. His Stepover was going 2.5% of that 1/16 of an inch, which worked out to be a little over 1.5 thousandths of an inch. Now, to put that into perspective here, what that means is the bit would take a pass, then move 1.5 thousandths of an inch and make another pass, then move another 1.5 thousandths. You can see where I'm going here. To put it into even more perspective, the diameter of a human hair is anywhere from 4 to 6 thousandths of an inch. He's not even stepping over the diameter of a human hair by running this 2.5% Stepover. Now, this is not to insult anybody. This is not to belittle anybody. This is just making the statement that there are very limited times when you would ever use a Stepover that small. And what I mean by that is if you have a model, let's go down here and find something very small. Let's get something detailed like this. Go into our modeling tab, and I want to set the size down to 1.5 inches. And apply that. I have a 1.5 inch diameter model here. In the case of something like this, that's when you would want to use something with that tiny of a Stepover. And in fact, in looking at this model, that 1/16 of an inch bit may be too big to do this model. You might want to go with the 1/32 inch bit. But this is about the only time that I could think of that you would use that tiny of a Stepover. That's not to say that it doesn't have its place. It does. Now, by comparison, again, I'm not recommending any of these settings, but by comparison, if we look at my 1/16 of an inch tapered ball nose, the last time I used it, I ran an 8% Stepover. Now, that's only 5 thousandths of an inch of a Stepover. That's still pretty tiny, but I was doing a small model at the time. This right here is more than triple the Stepover that he had in his setup. Now, if he's running a 30-hour machining time estimate, just by bumping that up to 8%, he's going to cut that time by 2/3. Just adjusting this Stepover to 8% will turn a 30-hour carve into a 10-hour carve. And even then, that may be overkill. It may not need that level of detail. If we take a look at something like this, something this small, then yeah, I can see maybe needing that level of detail. But if we delete that, come into our clip art, and go into a dome, and we make this pretty large, there isn't even a need to use a 1/16 of an inch tapered ball nose to carve this. We could come back over to a standard 1/4 inch ball nose, set a step over of 8 to 10%, and get a good finish on this dome. So my point in all of this is, there is no real right or wrong step over. The general consensus is anywhere from 8 to 10% step over when you're talking about a tapered ball nose or a standard ball nose bit. Anywhere from 8 to 10% step over is going to give you a good quality finish. Now, the larger the percentage, the more of a chance there is that you're going to have some cleanup. As I showed here, I tend to run about 8%. I get a good finish that needs minimal cleanup. If I find that I have too much cleanup on a particular type of material, I might go with a 7%, possibly a 6%. Again, it depends on the size of the project and how much detail I really need. So to keep things in perspective, don't just look at your percentage. Look at how much of a step over that is, whether you're using inches or millimeters. Look at what that unit of measure is. A step over of 0.005 of an inch is pretty tiny. But again, it's a 3D model. We want that level of detail. It also depends upon the model itself. Another thing to look at is feed rate and plunge rate. Now, if you'll notice, this is straight out of my tool database. If we look at this person's entry, this is a capture from his edit tool dialog within the 3D finishing toolpath. He's got his feed rate set at 50, which is fine. That's a good conservative feed rate to start with. But he has his plunge rate set at 60. General rule of thumb is the plunge rate should be half of the feed rate. That's a good baseline. Now, I do exceed that. If we look at my feed rate and plunge rate, I have 50 here, and my plunge rate is 40. It's more than half, but it's not equal to the feed rate. The thing to remember about 3D modeling, well, all cutting, as a matter of fact, is the machine will always travel at the rate of the slowest axis. And this counts whether I'm carving 3D or if I'm doing a pocket that I have ramped the plunge moves, or I'm doing a profile toolpath and I have ramped the plunge moves. When it starts to ramp in, the CNC is going to slow down and to 40 inches per minute in X, Y, and Z. The control systems of every major manufacturer are set up to do this to avoid damaging the tool or the machine. It will always slow down to the rate of the slowest axis. So in my case, we're looking at 50 inches per minute feed rate, 40 inches per minute plunge rate. So it will move over to this area and start moving at 50 inches per minute, but the minute that Z goes into motion, it's going to cut at 40. The X and Y will move at 40, the same as the Z. I can set this to 500 or 5,000 inches per minute. It doesn't matter. It's going to run at 40 because that's what my plunge rate is. Now, in the case of this other gentleman, he had his plunge rate set for 60, it's never going to reach 60 because his feed rate is 50. The machine will always move at the rate of the slowest axis. Now this is a big factor when it comes to 3D modeling because the Z is in almost constant motion. So in the case of my tapered ball nose here, that's why I have this set to above half of my feed rate, because the Z is in almost constant motion when you carve 3D, and that's the only time I ever use a tapered ball nose. So I wanted a reasonable feed rate. To get a reasonable feed rate, I set a conservative but reasonable plunge rate. And I can adjust this plunge rate outside on my control software as it's cutting. So, again, Stepover is a huge factor in the amount of time it's going to take to carve a model. The plunge rate is another factor. Now, base your plunge rate on the tool and your machine. Some machines are more than capable of handling a 100 inch per minute feed rate and a 100 inch per minute plunge rate, and that's great. Most home hobby CNCs cannot handle those kinds of speeds on a 3D carving. The other thing to remember is, even though this bit has a 1/4 inch shank, at the end of the day, this is still a 1/16 of an inch tip here and is prone to damage. It is very easy to plunge that bit too hard, too fast, and break the tip off of that bit. Believe me when I tell you this. Don't ask me how I know. So at the end of the day, it's still a 1/16 of an inch tip. We got to be a little bit conservative here. Once it's in the material and starts cutting, we can adjust up. We can adjust on the fly. Beware of your plunge rate, your feed rate, and your Stepover, and that will help you to reduce machining times, yet still get a good quality carving with a good level of detail. So, I hope you got something out of this video. If you did, I do hope you'll give me a thumbs up. As I do every Sunday, this afternoon at noon Pacific, 3 p.m. Eastern, I'll be hosting a live Q&A session where we can discuss the difference between the zero plane and the modeling plane, Stepover, plunge rates, feed rates, tapered ball nose bits, standard end mills, anything that I've covered in this video. Again, that's today at noon Pacific, 3 p.m. Eastern, right here on my YouTube channel. And I'll put a link to that Q&A session down in the description box of this video. Now, these live Q&A sessions are a great reason to go ahead and subscribe to my channel if you're not already a subscriber. And click that little bell button right next to that red subscribe button down there. Then you'll get a notification the next time I post a video and the next time I go live. So I hope to see you this afternoon. And as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch, and y'all take care.